Hi everyone, Mrs. A here. We are going to look at transformations of functions. So in our example, we're starting off with the parent function that is the positive root x. If you're not familiar with that, I am going to give you the parent function. In fact, I have it sketched down here. We're going to look at it in a second, so not to worry. It is important for us to get to know those parent functions, but if you don't know it yet, don't be afraid to graph it on software to get it so that you can work on the transformations work. All right, so we're going to state the transformations that are given to us here in this function notation, and then we're going to do a rough sketch of the new transformed function. So looking at this equation here, I'm going to pick out all of the transformations like we've talked about in class. So I'm going to start with this one here. I have here an a value that is -2. And an a value of -2 gives us actually two transformations on the graph. The negative for the a value tells us that we have a vertical reflection. And the 2 for the a value tells us that we have a vertical stretch by a factor of 2. So this means the y values will change sign so that it can reflect, and the y values will all be multiplied by 2 so that it stretches. All right, let's look at the next one. I'm going to actually go here because I like to do all my vertical transformations first. So this right here on the outside, that's a c value. And that tells us that we have a c value of +1. And to describe that transformation, we're going to have a vertical translation up 1 unit. All right, now let's go into our horizontal transformations. Right here we have a negative. It's a -1. That's a k value. Whenever you have a k value, you are going to stop and make sure that k value is factored out of the expression here, just so that we can ensure that we're applying the transformations in the order that we learned in class. So here k value is -1. It is factored out, so that's really good. And a k value of -1 means we're going to have a horizontal reflection. All right, and our last transformation here, that's a d value. Remember, the d values always change sign, so it's actually a +2. And that transformation tells us to move horizontally right 2 units. So the horizontal transformations here mean that on the x values, we're going to change the sign to get the reflection, and then we're going to add 2 to go to the right 2. If you don't want to apply these to the graph like using the sketch that we have, and you'd rather use the mapping formula, let me write that down, then you can do so. So you would take, you would take your original point, xy. And when I say original point, I mean from the parent function here, these key points that I've highlighted already, and you would apply the transformations in this way. Take your x and divide it by the k value, and then add the d value, and that would be your new x coordinate. And then you would take your y and multiply the a value, and then add the c value, and this would be your new y coordinate. So your old point maps to the new point, and you can do it that way if you want. Today I'm just going to apply these transformations right on the graph here. So looking at this first highlighted point on my parent function, the point is 0, 0. If it reflects vertically, it stays where it is because of 0 times a -1 is still 0. And same thing with the x-coordinate. If it reflects horizontally, 0 times -1 is still -1. Or you can think of it as divided by -1. It's the same thing. Okay, so let's do the transformations. We're going to go up 1 unit, and then we're going to go right 2 units. So we're going to end up, up 1 and right 2. That will be our new point at 2, 1. All right, let's move now this point right here. So for this point, let's start with the horizontal reflection. So a horizontal reflection means that the x value of 1 will become -1. So we're going to flip it over here. Let's do the vertical reflection. We flip here. And then we're going to multiply it by 2 vertically for the stretch. It's going to go right here. And then we're going to go up 1 and right 2. Whew, and it goes right there. Okay, so there's my new point. All right, so this is going to start going this way. Let me go up a little, this way like this, which is what we want because of the 2 reflections that are taking place here. Okay, so let's do now this point. Okay, so watch with me here. I'm going to have a horizontal reflection. So the x value of 4 will go to -4, and it's going to move right here. And the y value of 2 will go to -2. It's going to flip down here. And I'm going to take that y value of -2 and multiply it by 2, which will give me -4, and it's going to go right there. And now we're going to go up 1 and right 2. And right there is my new point. The new point there is at -2, -3 if you're doing this with the mapping formula instead. All right, it's looking nice now. Look at that curve. It's starting to take shape. Let's do one more point. So here we have 9, 3. So the horizontal reflection, the +9 will go to -9 over here, flipping it over. And then let's do the vertical reflection. So the +3 will go to -3 over here. And now we're going to take that -3 and we're going to multiply it by 2. That goes to -6 right here. And now we're going to move up 1 and right 2. And I'm going to land here, and that point is -7, -5. Okay, take a look at this curve. Let's sketch it in. Just roughly, because it is a hand-drawn sketch, so it's not exact. I'm a little off there. Okay, there it is. Our transformed function. Thanks for watching Mrs. A Loves Math.